In this video from ITFreeTraining, I will look at IP6 addresses. IP6 addresses are very different from IP4 addresses, and while they look complicated at first, by the end of this video you will have an excellent understanding of how they work, and they won't seem as scary as they first appear. The biggest problem with IP4 is that there are a limited number of IP addresses. IP6 has 2 to the power of 128 addresses, while IP4 has 2 to the power of 32 addresses. There are a lot of different ways that people have come up with to describe the difference between the number of IP4 and IP6 addresses. In this video, I will use the following example, and there are many more to choose from. If IP addresses were grains of sand, IP4 addresses would fill a truck. If IP6 addresses were grains of sand, they would fill the sun. Quite a big difference. IP4 addresses are running out. However, IP6 addresses should never run out. However, I hate to use the word never in the computer industry. With the larger address space, IP6 also comes with a new format to display these addresses. This is completely different from the way that IP4 addresses are formatted. The IP6 address is 128 bits. It would not be that easy to read in binary format, so IP6 addresses are shown in hexadecimal, grouped into 4s and separated with colons. An example of such an address is shown. Notice that all the hexadecimal numbers are in lowercase. If you are not familiar with hexadecimal, please see our previous video that explains how to convert and use hexadecimal. At first, the address looks complicated, but once you start breaking down the addresses, they get a lot less complicated. Also, once you start working with them, you will start to recognize particular addresses and what they do. To start with, let's break down the address into the smallest part, which is 4 bits and referred to as a nibble. With some tasks in IP6, like subnetting, the process is easier if the 4-bit boundary is kept. However, this is not always possible. The next breakdown is into groups of 4, which is 16 bits. There are a number of different naming conventions, and no one convention has been universally accepted for IP6. In programming, 16 bits is referred to as a word. In this course, 16 bits, or a block of 4 characters in an address, will be referred to as a quartet. Just be mindful that other naming conventions exist, and it may be a while before one is agreed on, if at all. The IP6 address is a little long and complicated, so let's look at how it can be made easier to work with. To make the IP6 address a little easier to read, first, the leading zeros in each group of 4 can be removed. To demonstrate this, I will use the previous example. By looking at the address, notice that there are a number of leading zeros. These leading zeros can be removed to give the following. You would not display the address like this, so the next step would be to remove the white space. This will give a small address that is easier to work with. There are, however, a lot of zeros left in the address, and it is possible to make it smaller. Let's have a look how. It is possible to compress an IP6 address by removing consecutive zeros and replacing them with a double colon. This is the example IP6 address from the previous slide, and we have 3 sets of consecutive zeros. These can actually be removed and replaced with 1 double colon. As you can see with the example, the zeros have been removed. These can actually be removed and replaced with 1 double colon. As you can see from the example, the zeros have been removed and there's white space between them. Once the white space is removed, you can see the actual physical address at the bottom. You can see that this address is much easier to read and recall now that it has had all the excess zeros removed. In some cases, however, you will have 2 sets of consecutive zeros, so let's take a look at that next. With IP6, consecutive zeros in an address can be replaced with a double colon in order to further compress the address and continue to make it easier to read. Here we'll take a look at an example of replacing the consecutive zeros with colons. The consecutive zeros can be anywhere in the address, but this replacement of the zeros with a colon can only be done once. In the first case, the first group of zeros can be reduced to a double colon. Consider the example again. This time the second group of zeros will be reduced. This will give the following result, which is valid. The point to remember is both are valid and they use a double colon only once. The last example, removing two sets of zeros, is incorrect and not acceptable in IP6. This is because it is not possible to expand it and get only one result. Looking at this third incorrect example, we could get one set of zeros in the middle and three at the end, or three sets of zeros and one at the end, leaving us with multiple possible solutions. This is why the replacement of consecutive zeros can only happen once. Later in the course, I covered the loopback address in more detail, but I will mention it here because it is a good example of zero compression. The loopback address is 7 groups of 4 zeros, or 7 quartets of zeros, followed by 3 zeros and a 1. Not something you want to be typing in if you can avoid it. Using zero compression, the address can be reduced to 2 colons and a 1. Much easier to type in. You can see that using zero compression makes the administrator's job a lot easier when dealing with big addresses. The next point I would like to look at is how would a port be added to the IP6 address. To do this, the IP6 address is encased in square brackets. A colon added, followed by the port. If, for example, the address is being used in a troubleshooting command like ping, the following would be used. If, for example, a URL was being used, the same process applies. The square brackets are required because if zero compression was used, it would not be possible to tell the difference between the port number and the address. For example, the 8080 in this example, without square brackets, would be interpreted as part of the IP6 address rather than a port number. The next topic I will look at is the network prefix. The network prefix is essentially the same as classless interdomain routing, or CIDR, which is used in IP4. You can see the following example of an IP6 address and /64 on the end. This is the same notation that IP4 uses. However, as we've learned, unlike IP4, the addresses can be shortened. So, for example, the following would also be valid. Unlike IP4, network prefixes are mostly used in routing. In IP4, the administrator would traditionally configure a subnet mask on a computer on a network, like a workstation or a server. However, in IP6, in almost all cases, a computer on the network will always have a network prefix of 64. In later videos, I will go into more detail why this is the case. However, for the moment, if you are in doubt, use the network prefix of 64. The last topic that I will go into in this video is zone IDs. When a zone ID is used with an IP6 address, this defines which interface should be used. In Windows, generally the zone ID will be the same as the interface ID. In some rare cases, you may want to do this. For example, if I were to ping the following IP6 address, I could add %2 to the end of the IP address to ensure that the ping command sends data out the second interface. In some cases in IP6, you would need to add the zone ID to an IP6 address to ensure the correct interface is used. At least now, if you see the zone ID used with an IP6 address, you will understand what it means. In later videos, I go into this topic in more detail. That covers it for IP6 addresses. You should now have a basic understanding of what an IP6 address looks like. They still, most likely, look long and complicated. In later videos, I will break them down even more, and you will start to recognize different IP6 addresses when you see them, which makes working with them a lot easier. I hope to see you in those videos. Until then, I would like to thank you for watching.